It happens to be very, very cold. So cold, in fact, that we have to store it in this special container called a dewar, and I even have to put special gloves on in order to insulate my hands. You guys want to see what it is? Any guesses of what it is? Shout it out. Oh, liquid nitrogen. Wow, you guys are smart. You might know that liquid nitrogen is officially the coldest thing here at the Science Center. You are absolutely correct. This is liquid nitrogen. So if I spoon it out here, it's doing something very funny. It kind of looks like water, but what is happening to it? Yeah, it almost looks like there's smoke. There's something happening. It looks like it's boiling. It is so cold that it's boiling off. It's turning from a liquid into a gas because, folks, liquid nitrogen is minus 196 degrees Celsius. That is so cold. That's even colder than it gets here in Calgary in the winter, even though it sometimes feels that cold. Okay, so I have an idea. You said we got to really reduce the temperature of this water balloon, this liquid water balloon, to turn it into a solid. Do you think it would freeze in our liquid nitrogen here? Should we test it out? Okay, let's put it in, see what happens. Whoa, something's definitely going on. Can you hear that boiling? Wow, it's going through an extreme temperature change. It's boiling inside of our dewar here, our container with our liquid nitrogen. So does anyone know what temperature water freezes at? Yeah, what do you think? Yeah, 0 degrees and below. So this is minus 196 degrees Celsius. I think there's a pretty good chance this water balloon's gonna freeze. So we'll leave that in there for a couple minutes while we talk about this awesome liquid nitrogen, and then we'll check on it. Okay, so we got our liquid nitrogen here in their special beaker. So you can see it's boiling off, and what's this stuff on the outside? Yeah, some sort of frost. It almost looks like it's freezing the outside. Well, it's so cold that it's actually condensing all the water particles in our air. Did you know we have water in our air? Yeah. Does anyone know a measurement of the amount of water in our air? You might have heard this on the Weather Network, or if you might have it on a weather app. Yeah, it sort of has to do with rain, you're right. It adds some water to our air. It starts with the letter H. It's kind of a mysterious word. Yes, over there. Maybe you could say it together. Do you know? Humidity, absolutely. Everyone say it with me. Humidity. Oh, it's kind of a weird word, huh? And that's a measurement, a percentage of the amount of water in our air. So 100% is like the maximum amount of water that could be in our air. Okay, here in Calgary, do we have a really high percentage of humidity or a really low percentage of humidity? Super low. Yeah, that's because we don't have much water in our air, right? We have a pretty dry climate here. We're not near the ocean. We don't have tons of lakes or ponds or marshes. So we get this condensed water vapor cloud a little bit here, but here in Calgary, where we don't have much water in our air, we can actually add our liquid nitrogen to more water to make an even bigger cloud. You guys ready? Okay, let's see it. 3, 2, 1. Whoa. And we get tons and tons of condensed water vapor because I'm adding the liquid nitrogen here to our awesome beaker full of water, or flask. And so we get an awesome condensed water vapor cloud. Now, if we were to do this experiment maybe in a place like Vancouver where it's a lot higher humidity, we might even get a bigger cloud. Be cool to test that out. Okay, I hear something happening over there. Should we check on our balloon? Okay, let's see what happened. We get all this condensed water vapor even on the top of our dewar here as well. So if we open it up, whoa. It is crackling. It's going through an extreme temperature change. Those particles we talked about, they're separating. They're moving further apart. And, oh, what happened to it? It's frozen. It froze. Oh my. And guess what? It's so cold I even have to hold gloves, or keep these gloves on while holding it. Wow. Super cold. Okay, so we know it's frozen on the outside, right? We can hear it. Do you guys think there's anything on the inside? Put up your hand if you think it's definitely frozen solid. Water freezes at 0 degrees and below, and that was minus 196 degrees Celsius. Okay, some of you think it's frozen solid. Who thinks that, you know what, there's something else on the inside? There could be a surprise. Water, air, or something else. Oh, okay, about half and half. How could we find out what is on the inside of this water balloon? I could cut it, yeah. I don't have a knife up here, though. What am I gonna do? Should I smash it? Okay. All right, you ready? You guys gonna give me a countdown? 3, 2, 1. Whoa! What is that on the inside? Water. There's water on the inside, so it's frozen on the outside. We've got a shell, a solid shell, but on the inside we have water. Well, that's kind of strange, right? Because that was minus 196 degrees Celsius. You're right, it is very cold water. So we know that it froze on the outside, but on the inside there is some liquid water. Okay, I want everyone to think for a minute about those frozen lakes and ponds that they see in the winter. Can you picture a frozen lake or a pond? It's frozen on top, but guess what's underneath? Water. Water, because, yeah, there's lots of animals that need to survive, and plants too. So that ice on the outside of our balloon or on the top of a lake, guess what? It insulates the liquid water below. It's really poor at transferring heat. So that ice, it helps protect and maintain the temperature of the water on the inside. Pretty cool, hey? And in the case of a lake or a pond, it would actually protect the lake or pond from evaporation. So we did an experiment with something super, super cold and water. What about something really hot? Should we try an experiment with some heat and water? Should we test that out? Okay, so you might have been wondering, what is that thing hanging from the ceiling? Well, let's lower it down and find out. What do you think it is? A balloon. Do you think there's anything inside? No. Oh. Mixed reviews. Okay, let's see. I'm gonna go like this and see if there's anything inside. You ready? Oh, what's that? Oh, there's water inside. What a big surprise. Okay, so we've got our giant clear water balloon with a tiny amount of water at the bottom. Okay. We also need a heat source, right? Because I said we used water and something really, really cold. Now we need some heat and some water. So guess what? This is going to be our heat source. I've got a lighter here. Now, the only thing that I'm missing for this experiment is a volunteer. And preferably a volunteer who's not too scared of loud noises and doesn't mind being in the splash zone. This is your warning, okay? So, I'm seeing some hands go down because of the splash zone thing. I'm glad I said that. Okay, I see someone right there. Yes, with, I believe, red glasses. Yeah, they're pointing towards themselves. Come on up. Thank you to everyone else who volunteered. Let's give everyone a round of applause for all the brave souls that volunteered themselves. Okay, so, you super prepared? You super excited? What's your name? Genevieve. Everyone say hello, Genevieve.
Hi.
Oh, fantastic. Okay, so guess what? I'm going to give you this awesome lab coat, aka splash zone protector, and these awesome glasses to protect your glasses, just in case. Okay, and then, Genevieve, if you want to come over here and verify for me. So this looks like a balloon with some water in the bottom, correct? Okay, fantastic. So guess what your job is going to be? You are going to be the holder of the heat. So I'm giving you a lighter there. What we're going to do is we're going to apply the heat underneath the bottom of the balloon, directly under the water, to see how this liquid water reacts with heat. Okay, everyone's seen a balloon, they're seeing some heat, so some of you might be thinking something crazy could happen. It could pop, it could explode, it could melt. So put up your hand if you think when Genevieve applies the heat under the bottom of the balloon, something crazy is going to happen. It's going to explode, it's going to pop. Okay. A lot of them think something's going to happen. Okay, put up your hand if you think, you know what, it's going to be totally fine. That water, it might react with the heat, but it's not going to make the balloon explode. Oh, okay, a few of you, okay. All right, well, there's only one way to find out, right, Genevieve? We got to actually apply the heat under the bottom of the balloon. So I'm going to give everyone a warning. We'll count down. Okay, so we'll light the lighter here. If you want to press that big black button there. Awesome, and then if you keep pressing it, there we go, we got our light. Okay, so... there you go, we'll move forward. On the count of 3, 2, 1. Oh, nothing's happening. Okay, let's check it and see. You can turn off the lighter now. Did anything happen under there, Genevieve? Not really, yeah, it maybe made a little singe mark, but nothing really happened to our balloon. It was okay. So do you think the water absorbed the heat from the lighter? I mean, it must have, right? Because that heat was touching right at the bottom of the balloon where all that water is. So I think it was absorbing that heat. We call this convection, where it's heating up the water at the bottom and being replaced with cooler water from above. The same thing happens to the air inside. But to truly test how insulating this water is in protecting the balloon, I think we got to apply the heat to the side of the balloon. Do you think we should do it? Okay, we'll give you a countdown warning. For those of you that are hesitant of loud noise, if you use the flat of your hands just over your ears like this, you can protect them. Okay, you ready, Genevieve? It's going to be awesome. Okay, on the count of 3. 3, 2, 1. Whoa! Did you get a little bit wet? Nicely done. High five. Let's give Genevieve a round of applause. That was amazing. I am going to have a lot of mopping to do later. That was so awesome. We'll grab your glasses and lab coats so we could see just how insulating that water was, right? Because as soon as Genevieve applied the heat to the side of the balloon, psh, it popped everywhere. Fantastic. All right, nicely done. That was awesome. Thank you so much. Wow, okay, that was pretty shocking. That was the most shocking thing that'll happen in this show, don't worry. Except for, we have another really, really cool experiment. Because now that we know that water can absorb heat, it acts as an insulator, I think I should light my hand on fire. Do you think that's a good idea?
Yeah.
Okay, I know a lot of you are concerned for my safety, and I really do appreciate that. But don't worry, this is something we practice here at TELUS Spark. We got lots of safety procedures. So, I'm going to light my hand on fire, but with the proper safety procedures. So, I got my lighter. This is my heat source. So, the next thing that I need is something to burn. I need some source of fuel. So, I think I should make some flammable bubbles. Does that sound good?
Yes.
Should we make some flammable bubbles? How can I make flammable bubbles? What are the ingredients for bubbles? Yeah.
Water.
Soap and water. Oh, okay. So, I got my soap here. Good old dish soap. I'm pouring it here into my giant bin of water, so I gotta kind of mix it around like this. Okay, I got my soap and my water, but these bubbles are kind of small, and is soap and water flammable? If I light this on fire, will it do anything? No, probably not. So I kind of need to fill these bubbles up with something flammable. So, guess what I brought? I brought a giant tank of some flammable gas. What kind of gas do you think this is? Liquid nitrogen, I heard, maybe? Or nitrogen? What else? What do you think? Did you have your hand up? Anyone else? Shout it out. Oxygen, hydrogen. Oh, all very good guesses. Oh, bubbles. Okay, so this is something that could be known as fart gas. There is a more scientific name for it. Does anyone know what that is?
Methane.
Oh, methane. Absolutely. You got it. Methane. So this is methane here in my tank. It's super flammable. We all produce methane. I produce methane. You guys produce methane. We digest things. They ferment. So I filled my bubbles here with flammable methane. So now I'm ready to light my hand on fire. So the first thing I got to do is I got to dip my hand in this super cold bucket of ice cold water. So that's going to be my insulating layer. Then this is my fuel. This is what is going to fuel the fire. Now sometimes it's tricky holding these bubbles on here because guess what? Methane is actually lighter than air. But I think I got it. Okay, you guys ready? Should we do a countdown? 3, 2, 1. Whoa, and my hand's okay. The water insulated it. Whew. Do you want to see it one more time? That was kind of quick. Okay. What if we turn off our lights here, and then we got a really cool black light here up above. So I think this will be awesome. Okay, ready? I'm dipping my hand in and grabbing my bubbles. All right, on the count of 3, 2, 1. Wow, and my hand's okay. Whew. Good thing I insulated my hand. Oh my. All right. Thank you so much. So, we know the water is a good insulator. That was proof. Okay, I have one last awesome experiment. Do you guys remember this little thing from earlier? What was in here? What was coming out of the top of this Erlenmeyer flask? Oh, something that looked like smoke or a cloud. Do you think we should make a bigger one? How can we make a bigger one? What are the ingredients? Yeah. Oh, hot water. Oh, for sure. Okay, well, good thing I brought something very special. Guess what's hiding in this container? A giant water balloon. Okay, if we're gonna make a giant cloud, well, we kind of need a giant container. So I got my giant balloon inside of my giant container. This has an awesome name. It's called a nitro geyser. Okay, so we also need something else. What is the magical ingredient? Because I got my water balloon. Anything else? Everyone shout it out on the count of 3. 1, 2, 3.
Liquid nitrogen.
Oh, liquid nitrogen. Oh, wow, you guys are smart. Okay, well, good thing I brought my super giant heavy container of liquid nitrogen. Whoa, we got lots here. Okay, so step 1, I'm going to remove the balloon here because at the bottom of my nitro geyser, I have a bucket that I'm going to fill with liquid nitrogen. Now, should I put a little bit of liquid nitrogen or a lot?
A lot.
A lot? Okay, well, the good thing about liquid nitrogen is I will add a lot, but it expands 700 times as it turns from a liquid into a gas. So, I mean, a lot of liquid nitrogen is going to make an even bigger cloud. It's going to be amazing. Okay, there's our liquid nitrogen. We got our giant water balloon. So we're going to place it on top here. Now, I kind of need to direct the cloud somewhere because we can already see there's some condensed water vapor, but do not fear, this is not the extent of it. So I'm tightening here the top of the nitro geyser so I can direct the cloud up into the air. Now, I have a water balloon in there. What should I do with it?
Pop it.
Should I pop it? What a fantastic idea. Okay, so here I've got my very special popping tool. You ready? Okay, let's count down. 5, 4, 3, 2, 1, and there we have our cloud expanding 700 times and then falling to the ground. Oh my. Okay, guess what? Because this is the finale of the show, if you would like to feel the cloud, everyone in the audience may line up along the edge of the carpet. We have to stay on the carpeted area. Adults, you can maybe help out. And I shall roll the cloud along the edge of the stage. All right, folks, thank you so much for joining me here at the Inspiration Stage. I hope you have a wonderful rest of your day.